Alrighty, everybody. I am back. Sure, you missed me, but today we're going to be talking about the carbon and nitrogen cycles. So get ready for a good time.
So last weekend, my family bought something pretty cool. Something I'm sure that you've always wanted. No, it's not a pony. It's a rotating compost bin. Yes, it's for compost and it rotates, which is going to be so awesome because the rotating part that allows it to get aeration. You may already know about compost. It's where biodegradable things can decompose, and the whole idea is after decomposing, the result is this nutrient rich organic material that you can provide your.
So you can throw, like you can see in this picture, your scraps of different plants and fruits and vegetables, and a compost bin. You basically put it in a pile, and you wait for it to break down, so that it can create nutrient-rich soil. So when you hear that things are biodegradable, that means that the earth can break it down. So these banana peels and apple cores and stuff like that can be broken down to create nutrient rich soil. It does take some time and it does take some skill, but nonetheless, it can be done.
Plants with. So I'm thinking after a while of adding leaves, banana peels, grass clippings, twigs, overripe fruit. I could keep going. After all these items break down and decompose, I'm hoping to get some nutrient rich material for my plants. So why am I even talking about this? Well, there are two major things that compost can supply plants with that are so important: carbon and nitrogen. We're going to spend some time talking.
Hopefully, we remember carbon and nitrogen from our macromolecules unit. Remember that carbon is in all of our macromolecules, so carbs, lipids, nucleic acids, and proteins all have carbon. And then remember CHO, CHON, CHOMP, so C for in CHO is in all of those. But N, nitrogen, is in proteins and nucleic acids as well. So they're a part of our biomolecules, and they're also super important for life in general. Like this flower needs the things.
About these two elements and their cycles because both of them are so important for life. With so many incredible elements on the periodic table, we don't know if it's really fair to have a favorite, but we do. It's carbon. Sorry, nitrogen, you're cool too, but why the love for carbon? Well, we really love how versatile it is. In one form, it could make up your pencil lead, which really isn't lead at all, it's graphite. It's a form of carbon. In another form, carbon can make up one of the hardest substances, diamond. The big four biomolecules, carbohydrates, lipids, proteins, and nucleic acids, they all have carbon. In fact, molecules that contain carbon are known to be organic molecules. Organic chemistry is a branch of science that studies the interactions of molecules that contain carbon. Just look at this carbon atom.
So
Just
beautiful.
look at it. It has 4 valence electrons, and carbon has the ability to form tons of compounds. Carbon is a building element in life for this reason. Well, now that you get the point on how important carbon is, let's make sure we understand how we get carbon. That means we need to take a look at how carbon can cycle. First, it's important to understand that there are carbon reservoirs.
So when it says that we need to know how carbon cycles, you guys are probably familiar with the water cycle. That is how you know it rains, evaporation, condensation, precipitation. So carbon, like this element, carbon has a cycle just like the water cycle does. Looks different than the water cycle, but nonetheless, all the carbon that has been here will continue to be here and continues to cycle through the environment in different ways. So does nitrogen and phosphorus and other things too. So they're all a part of a cycle, never ending, constant loop.
Basically, areas where carbon can be found, where carbon is hanging out. And the carbon cycle is a cycling among these reservoirs. So here are some major examples of where carbon is found. Carbon's dissolved in the ocean, it's in rocks, it's in fossil fuels, it's in living organisms, it can be found in the atmosphere. So the idea is to understand that.
So carbon is found in all of these places, okay? Living organisms, the atmosphere, different rocks and minerals, as well as bodies of water. So carbon's in lots and lots of places.
Carbon cycles among these reservoirs. Now, our time is limited, so let's take a look at one pathway. Consider carbon dioxide in the atmosphere. It's taken in by organisms that perform photosynthesis.
Remember, carbon dioxide is a input or a raw material, if you will, for photosynthesis. So it's super important for plants in order to make glucose.
This may be plants, it could be algae in the oceans or lakes. The carbon becomes a part of that photosynthetic organism. If the photosynthetic organism is eaten by an animal, it becomes a part of that animal too, and the animal that eats that animal. Both the plants and animals do cellular respiration, which releases carbon dioxide.
Remember that photosynthesis creates glucose, and then that glucose is created into ATP energy in our mitochondria during cellular respiration. Remember that plants and animals go through cellular respiration, but just plants go through photosynthesis. So we release carbon dioxide, that's the air that you breathe out, and so do other organisms like this deer and this wolf.
When the plants and animals die, the carbon they contained can be stored in sediment, and over a long period of time, they can even be converted into fossil fuels. Now, the burning of fossil fuels produces a lot of carbon dioxide, but too much of that leads to the concern of excessive carbon dioxide in the atmosphere. See, carbon dioxide is a greenhouse gas, which means that it can trap heat in the atmosphere.
So like all things in life, it's all about balance. We need carbon and we need carbon dioxide in our atmosphere for a variety of things, but if we have too much of it, too much of most things is not a good thing. So too much carbon dioxide leads to greenhouse gases, which can cause some global warming.
Too much carbon dioxide is not a good thing. Now, what about nitrogen? Well, nitrogen is a critical element in amino acids. Remember, that's the monomer of proteins. And it's also an element in nucleotides, which are the monomers of nucleic acids. And if you remember from our biomolecule video, proteins and nucleic acids are two very important biomolecules for life. Nitrogen is kind of a big deal in the atmosphere, considering it's the primary gas in the atmosphere. The thing about nitrogen is that it's much more useful to organisms when it's fixed into other more usable forms. Nitrogen can be fixed by bacteria, which could be living in the soil, or even in the roots of some types of plants, where the bacteria live in symbiotic harmony inside the roots, meaning the bacteria get a home in the plant root, and the plant gets...
Remember we talked about symbiotic relationships when we talked about the endosymbiotic theory, that the larger prokaryote bacteria, when they absorbed the mitochondria and the chloroplasts, they work together in symbiosis. So nitrogen's able to do that on plant roots as well. They work together for the greater good.
What's the benefit of this fixed nitrogen? Now, once again, we're just looking at one pathway. Here in the nitrogen cycle, so keep in mind this is just one way for nitrogen to cycle.
There are many
Okay,
ways.
so let's take a look at this nitrogen in the atmosphere. Consider the type of plants that have nitrogen-fixing bacteria living in their roots. The nitrogen is fixed by those bacteria in a form of nitrogen known as ammonia and ammonium. Nitrifying bacteria in the soil can convert the ammonium to nitrates and nitrites, forms of nitrogen that plants...
So just like all of our processes, they take some raw materials. In this case, it's ammonium and ammonia. And the nitrifying bacteria, these little green dudes here, which are found in the soil, are able to convert that into nitrates. And the nitrates itself are more helpful for the plant to live. They can't do a lot with the ammonium or the ammonia. They need it in nitrate form. So this nitrifying bacteria makes it in the usable form for the plants.
Can also easily use and assimilate. Now, animals can eat those plants and obtain that nitrogen. And when both plants and animals decompose, decomposers return ammonia to the soil in a process called ammonification, where it can be used to...
So if you guys have ever watched The Lion King, it's my favorite movie, so I've got to throw this in here. But there's a scene where Mufasa's talking to Simba and talking about how like the circle of life and everything's one, and when you die, you're returned to the earth or whatever. So, like, literally, when you die and you're buried, you can see here in this picture, this animal is releasing ammonia back into the environment where it can be reused again. So, literally, as things perish and are buried and they eventually decompose, they release these nutrients back into the environment.
And reused again. But not all the nitrates and the nitrites get assimilated by plants. No, there are other types of bacteria in the soil too. Drum roll. Denitrifying bacteria. And denitrifying bacteria in the soil can convert the nitrates and the nitrites back into atmospheric nitrogen gas. Again, this is one example of nitrogen cycling through. Keep in mind this happens in both aquatic and terrestrial environments, and
so both on land and in the water happens in both of these places in a variety of different ways.
There are other ways for nitrogen to be fixed and to cycle. You know how we mentioned that too much carbon dioxide can be problematic? You want a balance in these cycles. Well, there's a balance for the nitrogen cycle too, and nitrogen pollution can be problematic. Here's one example. Consider plant fertilizer. Plants love it. It contains a form of nitrogen. Well, if it's not used responsibly, the excess nitrogen in fertilizing crops can drain into bodies of water. And one reason this could be harmful is that it will basically cause an aquatic producer heyday. All of the algae and water plants, they now have this crazy load of nitrogen for growth.
So basically, if that nitrogen fertilizer happens to spill over into the ocean, it's going to cause a bunch of plants to be created in the ocean. And you're probably thinking, well, what the heck? We're always worried about not having enough plants. Why is this a bad thing? But if you look here, this algae bloom actually covers the top of this lake, which makes it really, really difficult for sunlight to break its way through. So that other organisms that are in need of that sunlight, or in need of like sunlight for photosynthesis, any plants that might lie down at the bottom, they will not get it.
And that might sound like a good thing, but all this producer excessive growth, it's messy. It can block light to the water, and then when they die and decompose, all that decomposing uses up a lot of dissolved oxygen in the water, which can be harmful to aquatic life who needs the oxygen. Whew. Now, you know, this recycling of carbon and nitrogen is pretty remarkable. Just think, you could contain a carbon atom that was once part of a dinosaur.
I honestly think about
because
that
of all this
all
recycling.
The time.
And the carbon and nitrogen cycle is just another beautiful thing connecting all of us. Well, I better get back to my compost. That's it for the Amoeba Sisters, and we remind you to stay curious.